In this video, we will be discussing how to calculate the volume of a pyramid and the volume of a cone. To calculate out the volume of a pyramid, we're going to take the area of the base, multiply it by the height, and then divide that by 3. So notice that the area of the base times the height, that's how we calculated out the volume of a prism. Now a cone with the same base and the same height as a prism will have exactly 1/3 of its volume. Similarly, same thing for a cone. We're going to take the area of the base, multiply it by the height of that cone, and then divide that answer by 3. Now recall that the height of a pyramid, it comes from that vertex and it goes to the center of the base. And then the slant height is the height of one of the faces of the pyramid. So this would be our slant height. Same thing with the cone. The height comes from the vertex and goes to the very center of the base. And then the slant height is the one on the side of that right triangle. So let's go ahead and try some examples using these volume formulas. In example 1, it says find the volume of a square pyramid. So to find the volume of this pyramid, I'm going to use that formula, area of the base times the height, and then divide that by 3. To calculate the area of a base, since it says it is a square-based pyramid, I'm going to use side squared to calculate out that area. I know the side of my base is 12, and 12 squared is 144. So I have 144, and then I'm going to multiply that by the height, which is 5, and divide my final answer by 3. So the final answer for the volume of this pyramid is 240 units cubed. Now let's move on and flip to the back to try some other examples. In example 2, we have a cone, so to calculate the volume of the cone, I'm going to take the area of the base times the height, divide it by 3. To calculate out the area of the base, since it's a circle, I'm going to use my circle formula, pi r squared. I know the radius is 16, so I need to square 16 to get 256. Pi is the area of my base. So I have 256 pi as the area of the base. Now the height of my cone is not given, but I noticed that this is a triple because 16 is the same thing as 2 times 8. 34 is the same thing as 2 times 17. So recall back to chapter 9, one of my triples is 8, 15, 17. So I have to do 15 times 2 to get my height of my cone, which is 30. And then I'm going to divide that by 3 to get my final answer for the volume of this cone to be 2,560 pi units cubed. So this next example is asking us to find the volume of a frustum. A frustum is the bottom part of a cone. So to begin this problem, we're going to start by adding the top part of the cone that is not showing. So to find the volume of any frustum, we're going to take the volume of the larger cone and subtract the volume of the smaller cone. Now recall that in order to find the volume of a cone, it's equal to 1/3 the area of the base times the height. So in order for us to be able to get these volumes, we need to somehow figure out the height of our two cones. So let's go ahead and draw in those missing heights. And notice that we have two similar right triangles here. So in order to get the height, we need to figure out what the corresponding sides ratios. are equal to. So we know that 12 over 15, those are corresponding sides in those similar triangles. I'm going to highlight them right here. And next, we need to find the slant height of the smaller cone, because we can use that to then help us find the height. So using similar triangles, we know 12 over 15 is going to be equal to the ratio of their slant heights. So the slant height of the small cone is just x. The slant height of the larger cone is equal to x plus 5. Okay, this whole thing is the slant height of that larger cone. So to solve for x, let's go ahead and cross multiply, and you should get 15x is equal to 12x plus 60. Next, I'm going to subtract 12 to get 3x equals 60, and then finally I'm going to divide that answer by 3 to get x to be equal to 20. So now I know the slant height of the smaller cone is 20. The slant height of the larger cone is 25. Looking at the right triangle at the very top, so I'm going to highlight that here in red, we can use now the slant height to help us find the height of that cone because it is a 3, 4, 5 triple. So we have 12 is equal to 3 times 4, 20 is equal to 4 times 5. So then we know that the height of that cone is going to be equal to 4 times 4, or 16. Now if I highlight the larger cone, the larger right triangle, so I'm going to highlight that here, to find now the height of the larger cone, I'm going to use these dimensions, 15 and 25. I know that 15 is equal to 3 times 5, 25 is equal to 5 times 5, so therefore the height of the larger cone would be equal to 4 times 5, or 20. Now I think we have all the information we need to go ahead and find our volumes. So if I go to find the volume of the larger cone, I'm going to take 1/3 the area of the base. Well, the area of the base is this base here. So I'm going to do 15 squared. I'm going to use pi r squared to find the area of that circle. So I get 225 pi as the area of the larger cone's base. And then times the height of the larger cone, I just found that to be equal to 20. Then to find the volume of the small cone, I'm going to use that same formula, except the area of the base, now I'm going to be using 12 as the radius. So 12 squared gives me 144 pi as the area of the smaller cone's base, times the height of the smaller cone, which we just found to be equal to 16. So now I'm going to go ahead and simplify those two answers to see what I get for my two volumes. For this first one, I get 1,500 pi as the volume of the larger cone. Then for the volume of the smaller cone, I get 768 pi. Now all I have left to do is to subtract these two from each other to get my final answer. So I'm going to do 1,500 pi minus 768 pi to get the volume of the frustum. And my final answer is 732 pi units cubed. So finding the volume of frustums is a little bit tricky, but just remember to add the top part of the cone that's missing and then subtract the volume of the smaller cone from the volume of the larger cone. So to find the volume of this figure, we're going to find the volume of the cylinder and we're going to add the volume of the cone. So the formula to calculate the volume of the cylinder is equal to the area of the base times the height. Now, I need to find the radius of the base before I can find this volume. So notice, if this is 16, that's equal to the diameter of my base, so I know the radius must be exactly half of 16. So that's how I get 8. So therefore the area of the base would be equal to 64 pi. Next, I need to find the height of the cylinder, since that was not given. Before I can find the height of the cylinder, I need to find the height of my cone. And I notice this is a triple. If I have 8 and 10, the height of my cone must be 6 because it is a 3, 4, 5 triple. Since this piece here, from here to here, is equal to 6, and this whole thing is 15, then I would subtract these two numbers to get the height of my cylinder, which is 9. So I'm going to go ahead and multiply that by 9 to get my final answer for the volume of the cylinder. To be equal to 576 pi. To find the volume of the cone, I'm going to use that formula, the area of the base times the height, and then divide that by 3. Now I already know the area of the base is 64 pi. The height of my cone I just found was 6, and then I'm going to divide that by 3. So when I simplify this, I get 128 pi as the volume of my cone. Now to find the volume of the entire thing, I'm going to add 576 plus 128 to get 704 pi units cubed as the volume of this composite figure. So hopefully now you have a better understanding of how to apply the volume of a cone and the volume of a pyramid formula.